Cool. Okay, so we're going to just do a very simple program using Java, and give me a quick thumbs up if you've started the Learn Oracle track. Give me a quick thumbs up. 1, 2, 3, 4, 5, 6, 7, 8. Keep them raised so I can see. A few seconds. Okay, cool. The emojis are starting to disappear now. Look at that. Okay, so try and find some time to start that. There are some useful things in terms of the context that we can chat through this week. Why does it exist? What kind of problems does it solve? Or always think about programming languages or tools that you use in terms of what problems they solve. You help set some context and how it works. So you don't need to worry about, as I said, going through setting up sort of like the Oracle Cloud compute instance. If you just want to run it locally, we're going to be running everything locally, so you don't need to go and provision yourself an instance through Oracle. It is free, but you have to go through the sign up process. But again, you don't have to worry about it, just you run it locally and ignore all of that if you want to. So the main things in the Learn Oracle track are just the context, and then start to explore how to compile and run some simple programs. At the end of the track, there's sort of a challenge to create a program using 2 classes, which is something that we've done a lot of. If you remember back in the software design module that we did, it's all about how do we use classes together. So we'll have a look at that. Okay, let me get rid of all your faces. So let's start off with a very simple Hello World program. And I'm not going to use an IDE for today, but tomorrow morning I will demonstrate using it and how we can set up a project. So I'm just going to do a very simple editor that I've been using so far, and we'll explore some of the reasons why IDEs will help speed up development using Java. But for the moment, because everything's so simple, we don't really need one. Feel free to, if you want to, start straight ahead in an IDE. For a very simple program that just prints "Hello World," we need a class, or we need a file. So let's create one. I'm going to create a Java file. All files that we write code in, source code, are going to be Java files like this, .java. They also have to be the same name as your class, and that you then define. So if I call my file "Hello World," I'm going to give it a class and the same name as my file. Hello World. Notice some of the syntax is quite similar to JavaScript that we've been using before. Note also the extra public keyword that I'm using to say this is a public class and is able to be used. Now every so Java library needs a main function. So you can quickly write a main function, and it has these 3 keywords to begin with. Public is something that we're going to just be more explicit about, and say what are exposed so class definitions and method definitions that other classes can use or have access to. Static just means it's at the class level rather than the instance level. So you might have already come across this in JavaScript when you're trying to define sort of class level methods. But what we mean is it doesn't return anything, and this is the standard main method that all Java applications need. So this is a class, and note how it sort of packages everything inside of it. encapsulates it. Classes in Java are a way to encapsulate your code. I just want to print out hello world. So in the same way that you were thinking about JavaScript, JavaScript does something like, or Node.js does something like process standard out, and then we give it a string, or we can use console log. But in Java, we just use system out, and then we can print. So print or print line, depending on whether you want new line characters at the end of it. So in this way, let's use hello world. Anyone know the significance of this of hello world? Why people use it?
First thing typed on a computer.
Say again, Jamie.
First thing typed onto a computer.
Yeah. Imagine that. Or at least the first thing produced by a computer. Cool. So let's have a look. So we have a class, and we've got a sort of our main function that gets run automatically. So let's now go through the process of trying to run it. Now, in order to run this, we need to compile it first. Now, this step of compiling and running is something that your IDE will do automatically for you, so you don't need to worry about it. But given that I'm not using IDE, you have to do it manually. As you might have remembered going through the Learn Oracle track, one of the main advantages to using Java is the fact that it's platform agnostic. So you can write code, but you need to compile it. But when you compile it, it makes it so that any sort of platform can understand it, because the system that it uses to compile and interpret it is platform dependent. So you have two parts to this. You have you can write your code and then compile it, but then when you actually execute it, you execute it inside of an environment. So imagine if you think back to running JavaScript, you can write JavaScript, and then depending on your browser, if it's on your local machine, there are different environments that you can run your code in. So the same kind of thing happens with Java. You can write your code and you can compile it. It compiles down to what we call bytecode. Bytecode is so the layer in between source code and machine code. And machine code is what is sort of attaches to your hardware. It needs like some actual hardware processing, to execute the instructions. But it depends on whether you're on Mac OS or Windows or whatever, or Linux, what is the kind of hardware and what kinds of instructions it needs to run. So you install your Java environment on different platforms, and then you can execute your code on whatever platform, because bytecode is always the same. So this gives one of the main advantages to using Java, because it's platform agnostic. It's also object-oriented, so you use classes and methods and encapsulation, all the kinds of things we've been doing over the past few weeks. So back to the step I need to take, which is to convert my code into bytecode, and I just run Java compiler, Java C to compile it, and I give it sort of the direction of where my file is. That's the Java file that I want to compile. It spits out any error messages if I get anything wrong. So imagine if I had missed out the semicolon. It gives me an error message at compile time. So I'll go fix it and run it again. Cool. So notice when I run this command, I produce this other file. That's not as quite readable, is it? It's got loads of characters and weird things in it. But there's information here about what it needs to do to be able to run this program. So in order to run the program, I'm going to use Java and then the file name. and it just is the class name like this. Hello world. Fun times. So there are two steps there. We compile our program. It produces a class file, that's bytecode, and then we run that class name using Java. So two commands here: Java C to be able to compile it, and then Java to run it. Two steps: compile and then run. We have to make sure we get the name of the class the same as in the file as it is in the class. And every so Java program needs to have a main function like this. If you're running an IDE, most of these things are created automatically for you, but we'll have a look at doing that tomorrow morning together. But if you've already ahead playing around with your IDE, whether it's NetBeans or IntelliJ, that sounds great. Let's do like maybe one other example that I was thinking about as I thought about demonstrating this morning. Let's do another example where I use sort of two classes together for the moment in a simple fashion. I'm going to have like a main class in this example. So if I call it main with a capital letter main, my class has to be where did those brackets come from? Has to be a main class like this. I need a main method, so I'm going to create it. I want to create an instance of another class that I will define elsewhere. One class per file. That's a convention we should be familiar with by now. So I want to do something like the output I want is just to sort of give like a hi and then a name to someone. And so I'm going to create a class that does this. Now, one of the things that we have to remember with Java is that it relies on types. So we have to explicitly say what type things are. This is important. I can't just say, for example, I define that a variable greeting and assign it a value. Let's say I want to create a new instance of a greeting and give it a name. Anthony, you're in my top left, so let's do Anthony. Now, I can't just assign a variable like this. Java wants to know what type greeting is going to be, what is going to be stored in this variable. And so in order to do that, I need to say, okay, well, the type, if I'm creating a new instance, is going to be of a greeting type. So I just put always the type before the variable. And there'll be a few other places that we put types just before things that we need. So this on line 3 says, I'm going to store my greeting variable, lowercase, I'm going to store inside of it a type greeting. And then I assign it to the value of whatever this is. Always remembering semicolons. And then I want to print something. So let's go back to the way that we print. I want to print the greeting, and let's just give it a good old-fashioned string method to sting. Unfortunate. Okay. Something like this. So I'm going to at some point define my class and then define it to string method for my greeting class. Now, in order for classes to be able to sort of talk to each other, we have to put them all inside of a defined package. So at the top here, I'm going to say what my package is going to be called. And this is conventionally always the same as the directory in which your Java files are in. So I'm in the greetings directory, so I'm going to call this the greetings package. So I'm going to define my greeting class. I'm going to go to here. Greeting is the name of my class. I'm just going to be the name of my file. And it's going to be the same package. So greetings. And I'm going to make it able to be exposed, so my main class can also see it. So public class greeting. So this is inside of my class greeting, and I needed some kind of constructor function to pass in. As we've been doing in JavaScript, we have a constructor function. In JavaScript, we'd write it with an actual constructor like this. In Java, we give it the same name as our class name. So it's a public method, and it's going to be the same name. So here, I need to think about, well, what kinds of arguments do I need? And the type here is string, because I'm passing in a string. So I declare the type. And I give the name of the argument, so something like name maybe. And then I need to sort of set the variable. And the way that we do this is thinking about scope. So I'm going to declare a variable outside of it, again type string, and let's give it a name. Greeting name. So I declare the scope like you're familiar with using JavaScript. We declare the scope, and the only difference here is we have to declare what type it is. And then I can use it here. So I can say whatever is my argument is going to be a string, store in the variable greeting name. So I now have access to this variable. I need a toString method because I'm using it here. Let's see if we can see on the same page. So it's going to be public. I need a toString method, and this has to return something. So I want to format the name. Java has a sort of string method, string format, and I want to format it. The way that we can do formatted strings in Java is to pass it a series of sort of placeholder variables inside of a string. So we'll do something like hi, and then placeholder variable number 1, something like this, and this represents like the first sort of substitution I want to make, and inside of here is where I'll put greeting name. So it will replace, when it forms a string, it will replace this with greeting name. Cool. So simple program using two classes together. I've got my main class that creates instance of greeting, and then prints out the return value of greeting to string. My greeting class takes in, when I construct it, it takes in a sort of name input, and then has this to string method that formats it. Quite simple, quite straightforward. I've got two classes, greeting and my main class. And then now let's go ahead and try and compile it. So Java C, let's go outside of this directory. And might as well go into this directory. And let's go ahead and use our Java C to compile our main class. We need to have a look at this error message. The error message here says cannot find symbols. So there's going to be some error in the way that I've told my program to find the greeting class here. We're in package greetings. I probably need to make sure I can see the other class. It should be fine. Okay. Invalid method declaration, return type required. So I need to define for this method what kind of return type needs to be. So if I think about the return value of this method, I always want to return a string. So I need to make sure I define my type here in the same way that I've been defining the types for this input and for this variable. My method also needs a type. What is this going to return? So my method to string, I always want to return string. And so this gives you a little bit more of an idea about being explicit with inputs and outputs for your methods. You always should be thinking about what kinds of things go into my method and what kinds of things are going to come out of my method, and be clear about what types they're going to be. Cool. So having added that in, having read through the error message, making sure I understood the return type that's required, I've then compiled my program, and you can see it generates both of the classes over here, both main and greeting, and now have their corresponding class files. So in order to run my application, I use Java, and then I can run it, and it says, "Hi, Anthony." Thanks for the wave. If I needed to change it, so next below my list is Josh. If I wanted to change it, I can't just run it again. It's still compiled to say hello to Anthony. Sorry, Josh. In order to see the next name pop up, we have to recompile it. So compile and then run again. And now we see Josh. So what I want to do is just demonstrate some of the differences between how we've been using JavaScript and now thinking about being more explicit in the types and also the public-private aspect of our classes and methods. When we use an IDE, and we'll talk about that tomorrow morning, a lot of the manual steps of compiling and running is abstracted away. You don't need to worry about that. That's done automatically for you. But it's good just to play around for the rest of today in being able to do it manually for yourself. Understand the different steps that need to happen. Looking at the errors and understanding them. Cool. So therein, I want to finish that short demonstration, and maybe let's have any questions or thoughts before we disperse for the morning.
So there's public and private.
Yeah.
Private mean that another like Java file can't see that.
Exactly, but that's a file. It's just about classes. If it's private, the other class can't see it. In the same way, I was saying the same that we've been using with JavaScript, but we haven't really encountered that yet with JavaScript. By default, we're always going to keep things. Okay, hold on. For the moment, all of our methods and classes are going to be public, and then we'll think as we get a little bit more familiar why we want to keep some of our methods private. All right. So for the moment, public is fine to keep all of your methods and classes. The rule of thumb, however, is always going to be private where possible, and because it's again about thinking about scope. What can other classes see the less the better. And we're trying to keep interfaces to our classes, not a Java interface, but just like what is exposable, as small as possible. So at the moment, everything here has to be public because I need to be able to call, have access to the class, be able to call its constructor and then call its method. But if I had any other helper methods, I could keep them private. And so I wouldn't be able to call outside of the class. We'll talk. I think we'll probably talk a little bit about that on Wednesday or Thursday, maybe the end of Wednesday or early Thursday.
You might have mentioned this, but so why did you use the public static void main function in the main class, and why haven't you used it in the greeting one? Like, what's the exact role of that method?
Yeah. Every Java application needs one main function. This is like the app runner. It's what creates and runs your program. So think of it as like the top level executable sort of part of your application. Every Java library has to have one. And this, when I run it, this is what gets called, and it creates everything. So I need to have some kind of main function. I can call the class whatever I want, but if there are two main functions, my program will get confused. It needs one main function. And as a result, it has to be public, it has to be runnable, it has to be static. So it's at the class level. I only need to create an instance of my main class, and it doesn't return anything, it just runs. So it needs to be public, static, and void. And then this is the way to denote if I need any arguments. This is the type. There'll just be a list, a string array. So whenever you write a Java program, you need at least one. You need one main function, no more than one.
Okay, cool. That makes sense. Thank you.
Cool. Other questions, other thoughts at the moment?